Thank you so much, Mike. It's a great pleasure to be here at the ICCV workshop on shared stories and lessons learned. Yeah, as Mike mentioned, this kind of talk is best given when we have the opportunity to interact with the audience. So please feel free to put in questions on chat or your responses, as well as connect. Feel free to turn on your video and just interrupt in the middle of the talk. We'll of course have a panel discussion during the workshop itself, but just please encourage folks to participate here as well. All right, so I'm going to talk to you today about my experiences working in industrial research. It's a personal perspective, and because it's part of these kind of shared stories and lessons learned, you hear a lot more about the things that go wrong than the things that go right, because the things that go right you hear about in lots of places. Also, I'm not going to present any detailed technical material, but I'm happy to talk about any of that stuff in the talk itself. So what is it that I do these days? So at Google, I'm co-leading a the machine perception team, or the perception org in Google Research. And so it's about 500 people located over many different time zones, many different sites. And we build technology in machine perception that's critical to a lot of Google's products and services, and is used across Alphabet. So things like Google Search, YouTube, Photos, Cloud, Pixel, Nest, Waymo, others. We collaborate closely with those teams to connect our technologies. And also, researchers in our teams have been very active in advancing state of the art in terms of computer vision research. And you'll see papers from our group in conferences, ICCV included, as well as open source contributions and so on. My personal research interests lately have been around video understanding, and I still continue to do some work in that area, but as my org has grown, I've shifted my focus more towards leading that organization, and then also there's been a shifting balance between external and internal opportunities, some of which we'll talk about during the talk today as well. And in addition to my role at Google, for a long time, last 10 years or so at Google, I was very active as adjunct faculty at both CMU and UCF, where I really enjoyed working with PhD students and collaborating on papers and so on. But in the last year or so, I really had to ramp down on those fronts, and I have very few collaborations now because of the time constraints, but I'm still excited. I'm also very excited to connect with students, particularly in cases like here as well. So be happy to take questions as we go. All right, so for me, my research journey kind of started when I saw there was a Byte magazine article in 1989 that talked about using neural nets to drive these self-driving cars. At that time, I was an undergraduate student, and I was like, wow, it would be amazing to get my PhD in something like this. And so I had the opportunity to go to get my PhD at CMU on this project. Does anyone know, I mean, maybe it's too old now, but anyone know on the audience what this vehicle is or what this robot is? No guesses. It was called the NavLab project, and it was one of the very first attempts to do autonomous navigation. What you can see is it's actually a big van. And the reason it's a big van is that in the back, there's a generator, and there were 3 or 4 Sun workstations that were running to power the perception system. And there's a laser rangefinder up there, as well as a camera. And at the time that I did my first project, it was impossible to process every frame. And in fact, we chose to drive at night so that we would have to process fewer pixels. We could ignore most of the dark image and then just track taillights. So it's a lot has happened since then. Of course, during the time I was doing my PhD, neural nets died, so they got replaced with things like SVMs. All the funding for self-driving cars, it became dried up, and there were not that many opportunities for people who were getting their PhDs in robotics because it was too early, too weird. So for me, I really had to rebrand myself towards the end of my PhD as being really a computer scientist who was doing, work. Yes, it included things like robots, but I had a broader thing. And and also as neural nets died, I had to become much more of a hardcore computer vision person. So for me, it was really interesting that 20 years later, you can see the neural nets hot again. Everyone's really excited about neural nets. Everyone was saying that they want to work on self-driving cars. Everyone had their own self-driving car startup and so on. And then, of course, robotics became very popular and became like a way to kind of get entry into a lot of interesting places. So both in industrial research and academia, things change. So really, one lesson that I got through through the 90s and 2000s and so on is really that things can change, and things can change based on ways that you don't anticipate. So really, if you look at my journey through the industrial research labs, after my PhD at CMU, I went to work at a company called Just Research. It was a really interesting lab doing AI work, but after a few years, the parent company could no longer afford having a research lab that was just doing research, and it had to shut down. And it shut down not because of the work that was done in the lab, but more the business context. The parent company was in competition with Microsoft at the time, and Microsoft, was able to dominate the market, and the company that was funding us was just unable to afford the kind of luxury of a research lab. So industrial research requires you to have enough of a long-term view that it makes it attractive to have people working on things that are not immediately relevant. After that point, I worked at a research lab that used to be a digital DEC. It became Compact Research Lab. It was in Boston and Cambridge, and it was a fantastic place. I had I had awesome colleagues, and we were doing really interesting work. A couple of my colleagues came up with the Viola Jones face detector at the time, and there was a lot of other interesting work in both in speech and projectors and cameras and many other things. But again, it was a tricky time for industrial research, and the labs, for a variety of reasons, decided to lay off people. So even in the time I was there, I lost a lot of my colleagues. There would just be layoffs, and people would have to find other jobs. And so, and at that time that we were working there, computer vision was not seen as that important, because back in 2000, it was just computer vision was much more of a seen as, oh, it's never going to work, too far out. And the same was true for speech by the time. Of course, after a lot of my colleagues are laid off and the lab was pivoting to some other areas, the company merged with HP Labs in 2001. And so we got rebranded. We were an HP Labs company. And suddenly computer vision was important again because HP was doing work in imaging, cameras. Unfortunately, the business itself was not that healthy. And even though our work was more relevant to the company, there were still more layoffs and more of my colleagues that go. And so in 2003, I made the decision before the lab closed to join yet another lab in Pittsburgh. So I was back in CMU, where I had the opportunity to connect much more closely with faculty colleagues at CMU. And I joined a place called Intel Research Pittsburgh. And there it was interesting because the company that was funding the lab, Intel, was a hardware company, but the work we were doing was software and was much more open source and published openly. It was again a place where a lot of interesting work happened, but over time the company's focus also shifted. So rather than having these long-term research labs that were working on industrial research that would someday have relevance to the company and the world, they decided in 2011 to shift focus and consider having shorter, more focused labs in various areas. I had the opportunity to lead one of those labs, but it was also a good time for me to reconsider other opportunities, and that's when I joined. Google, and I've been at Google for about 10 years, and I've really enjoyed working there. But if you look at my journey, you will see that every lab I worked at is dead. And that's an important lesson for people who want to go into industrial research, because it can seem like it's an awesome place and that you're promised, infinite freedom and infinite possibilities. But the reality is that, you are very much at the mercy of the global context around you. And no matter what you do or how well you do, the industrial research journey can be non-monotonic in the most generous sense. So for people who are interested in industrial research, you have to be comfortable with this. I have fantastic things to say about Google, but I think it's important to have the wisdom to understand that industrial research in tough times is always going to be seen as a luxury. So right now we're in a really good climate, but if you go into industrial research, keep your eye out for the long term. All right, so in the previous couple of slides, I really said you should expect things to change. What do I mean by that? At one hand, I mean that the research trends, let's say the work that you do for your PhD, it's going to be different over the years that you are in an industrial research lab. So you shouldn't expect your PhD research to define what it is that you do through your research career, but you don't necessarily expect it even to survive. In reality, you'll find that if you're in a field that's exciting and growing, the work you do during your PhD will become obsolete. So really the skills you're learning during the PhD are not the ones that are going to sustain your career, it's the meta skills. How do you learn? How do you adapt your research? How do you learn new fields? And so in industrial research, it's important to understand the work you do in connection with the priorities in your company. So it could be that the work you do is disconnected, and that could be okay if you have the freedom. So I've been in research labs where the work I did was not that valued by the company, but I valued the freedom and I valued the opportunity to work on it, and I felt that the work I did was important enough to be worth doing. But in sometimes it's also important to see, what is the alignment between the work you do and the needs of the company, because that can help you get the resources you need to drive that research forward. Second point is that in industry, particularly in the US, there's this notion of kind of people are suddenly hiring in an area and then they can be layoffs. So these kind of boom and bust cycles happen, and they don't happen because of what you do. They happen because of the more global economic conditions and how your field is doing. So in industrial research, you have to realize that there's a stochasticity to the environment that you may not appreciate as a PhD student or even as a junior researcher in some of these areas. So sometimes you may ask, why is it that we're hiring right now, or why is it that we're laying off or shrinking projects or canceling projects? There could be a variety of different reasons. But one reason that can definitely happen in industrial research more than can happen in academia is that in industry, you can have a change in leadership. You can have a new director for your lab. You can have a new vice president coming in who's emphasizing one area over another. You can have your CEO of your company can change. Your company can get acquired, or your company can realize that it needs to cut costs in a global way. And you can see that those changes in leadership can have dramatic effects on the work that happens. In some cases, the work can be deprioritized, become relevant, or you may be encouraged now to switch research fields from one area to another. And that'll happen in a way that's much more direct in industry than it would be in an academic setting. It's also instructive to reflect on the industrial research labs over the years. There are many labs that were amazing in their heyday, Bell Labs, IBM, Microsoft Research, and others. And over the years, they've had to change their models. Sometimes the labs, Xerox PARC, sometimes the labs survived those changes, and sometimes the labs didn't survive, or sometimes they mutated so much that they're no longer able to attract the same kind of talent that they could in their heyday. And so if you're working in industrial research, you have to become comfortable with change. It's going to happen whether you want to or not, but the way you react to that change is somewhat up to you. So the sudden change can of course be stressful, but once you get over the stress, you can see what the opportunities are. Sometimes the opportunities are within your company. You have the opportunity to change how things go. And sometimes the changes are going to reveal opportunities that are outside your company. Colleagues of mine faced with change, sometimes said, okay, now's a good time for me to change from the company to go to academia. Or in some cases, it's to create startup, or it's to create a uh, new piece within your company where you can explore the kind of research that you believe is important for the next opportunity. One lesson that I think I've learned over the years is that when you go to a conference like ICCV, you see the same researchers made from your generation, the people you got your PhDs with, or the people you work with, same researchers are there, but they're wearing different badges. And so why is that? It's because they've changed roles, within the company or in different companies. But the successful researchers have often had some level of research visibility or personal branding that enabled them to go from one situation that was trending downward for reasons beyond their control to another opportunity. And so as a researcher in industrial research, it might be useful for you to think about what is it that you're doing that is focused towards this company, and what is it that you're doing that's transcending it in a way that's maybe broader and more useful. So as an industrial researcher, you have to learn how to adapt, how to survive, and ideally how to thrive in almost like in a anti-fragile way amidst the change that's going to be coming at you. And particularly the message I have for PhD students and junior researchers is don't view the last few years as necessarily a way to extrapolate into the far future. We're all liable to want to extrapolate, but none of those extrapolations have much merit, and particularly I'm always wary of people who promise exponential anything, because exponentials by their nature can't survive for very long periods of time. So what are some of the differences we see between industrial research and academia? The first one, I think, is around solo versus team research. When you're working in academia, there's a lot of incentive to do solo work. In industry, that's also possible, but increasingly we're in an era where I think how you work with a team becomes very important. So the skills that you might develop as an individual researcher, they're important, but there's a separate set of skills that you need to know: how to work well with a team, how to lead a team, how to work well with other teams, how to resolve conflicts when there are multiple teams doing similar things, and so on. And industrial research is going to require you to exhibit those skills. So take the opportunity to learn those skills in your current role. Second one is also publications. It's important to think about publications. When do you publish and why do you publish? Some cases, some labs also do patents and some don't. But with publications, I think I'd like people to think about it. As a junior researcher, you're often thinking about what's my next ICCV paper, what's my next CVPR paper. But over your career, you have to think longer term, as in not be focused on paper to paper, but rather what is your research agenda that's going to go over multiple papers. And I think you also have to be resilient to the fact that your best papers that you, at the time that you wrote, may not be the papers that survive the test of time. And that's why conferences have these test of time awards. But it's important for us as researchers to also have some degree of humility that we may not be able to anticipate, 10 years down the line, which of our work really is gonna survive. In industry, there's also a tension between curiosity-driven research, I wonder whether this will work or not, versus mission-driven projects. And I don't think that one is better than the other. There's roles for both of them, but it's important to understand when you're working, what kind of a project are you on? What kind of a mode are you in? And to make sure that you do the right thing for the project you're on. In mission-driven projects, maybe you don't have the luxury of doing the curiosity-driven research as much because there's time urgencies and other things. But on the other hand, you have sometimes opportunities for a lot more resources. And so as a researcher in industry, think through, if you're as a junior researcher, what kind of project are you on? What kind of project do you want to be on? and think about that for your next project as well. And if you're in a more senior role, what kind of project are you leading? What kind of incentives are you providing? And what kind of implicit assumptions are you making in the projects that you're driving? And also it's important to understand, how does your lab measure impact externally, internally, and so on? And these are some of the things that I think are natural questions for us to ask. Again, if people have thoughts or questions on chat or in person, I'm happy to take them. So at Google, we really think about, in Google Research, I really think that these are 4 dimensions of research projects that lead to different kinds of outcomes. And it's not that a project falls into one of these categories for sure, but they exhibit greater kind of dot product with one of these canonical axes. And so I find these 4 project dimensions to be useful when you're starting new projects, or when you're reflecting what kind of project you're running, because they lead to different kinds of success criteria, different kinds of incentives for collaboration, publication, and so forth. So in the top left, we have basic and fundamental applied research. And this is research that's creating new capabilities. It's research that is typically advancing the state of the art, not just internally, but in terms of external metrics. And it's the kind of research that we often prioritize in terms of top-tier publications, academic collaborations, and so on. If this was a more interactive session, I'd invite the audience to, what are some examples of this that people want to put in the chat, examples of projects they know or papers that have come out in fundamental applied research. It'd be great to hear from you. While we're thinking about this, let's also talk about the critical product contribution. So this is technology that you're developing in industrial research that's really powering key features in whatever it is that your company does. So in Google, that might be doing something that's very critical to YouTube, or something that's computational photography features for the Pixel phone, things like that. And it can really advance a project forward or product forward, or it can transform an existing business in new ways. So for example, Google search in the past didn't use anything from kind of features like images, but over time, as computer vision got better, it relied more and more on that. Similarly, YouTube for a long time didn't use visual features, but then as computer vision technology got better, you can imagine that YouTube was able to use content-driven features for so much more. And they had significant advantages when shifting there. And then, of course, you can transform an existing business entirely by the presence of having really good computer vision technology. The Google Photos is an example. There's no other metadata available typically, and it really relies on having good computer vision at its core. Similarly, you can have things like object detectors. Having good object detection changes what Google can do in robotics, Waymo, and so on. The third dimension really is infrastructure. So broad adoption in this project is important, whether it's internal or external. And that can mean that you improve the efficiency, reusability, scalability of these things. And the idea is to reduce development time, bugs, and other things. So good project in this direction might be something like TensorFlow, which gets used a lot externally and internally at Google. But there are many examples of infrastructure projects that are more computer vision specific that have come out. So from our team, there was a project called MediaPipe that was used a lot, as well as object detectors from Google, and many other companies, Facebook, OpenAI, and others are providing really good infrastructure to help people. And even infrastructure like Colab notebooks and others can be really exciting to have. And then the final category is new product innovation. So this is where the technology that your project develops can create a new business or new product category. In some cases, people might think robotics might be an example there, but one that I think is more obvious to people may be some of the assistance that you get in Nest, the Nest cameras, or the Nest tablets with cameras, where you can have interactive perceptual interaction. Those kinds of things are examples of new technology or novel combination of technologies that without the project would never have existed. And that category tends to have more risk. It tends to have fewer papers and fewer launches, but it's important to nurture projects like that. Otherwise, longer term, you may not have the innovation you need for your business to succeed. People often ask me, when I'm mentoring them or in one-on-ones, both internally Google or externally, what kind of projects should you work on? And in general, we're at a time where, highly skilled, awesome people like yourselves, you have the opportunity, maybe you can do anything, but even you, with all of your skills and time, that you don't have, even no matter how much energy you have, you can't do everything. So it is important to consider what is it that you're going to work on. So I think about it increasingly, not from an individual researcher perspective, but rather what are the projects we want to have in my org. And I consider four questions when someone's interested in starting a new project, and I ask people to reflect on them. So these are research questions that we've been using in machine perception for some time, but I think they have applicability beyond our group, and I think you might find them useful. So the first one is to ask people to clearly articulate what's your research hypothesis. It's not the same thing as saying, I'm excited about working in video. That's not a hypothesis. You might have a specific hypothesis. You might say that right now you believe that because of the compute capabilities and the new algorithms that you have maybe around, let's say LSTMs or transformers or whatever, that you think it is now time to do work on action recognition. And you think that in the next 2 to 5 years, you think that it will be possible to do action recognition with sufficient accuracy for X, Y, Z to happen. So if you have that research hypothesis, then it's possible to test it. It's possible to measure it. And so then I might ask you, if this hypothesis were true, what's the best case scenario that you're going to create, either for us as a company or the world itself? And so that helps you to think about it, is that if you put in all this hard work, is the upside of that sufficiently compelling? Is it either sufficiently ambitious or is it sufficiently good for us to invest the time and energy? And it's important to think about that because we all have opportunity costs. If you don't do this, you could do something else that maybe has more impact. And so it's important to think through question 2 carefully. The third one is, who's going to work on it? Sometimes you might have a great idea, but you don't have the skills to pull that idea off. And in that case, the question is your company able to hire people with those skills? Or do you have the opportunity to train yourself in these skills? And it might also be an opportunity to say, who should you collaborate with to work on these things? Often people say, oh, it'd be great to do more with quantum computing and X. Okay, but do you have the right people to work on it? Or I'm interested in using AI for healthcare in this area, or AI for medical problems. And in question 3, it's important to reflect, for the project to be successful, do you have the skills and the resources to make it happen? And then the fourth one is, it's important to have strict eyes as a project lead on your own project. And it's very easy for us to imagine that we're making progress because you could be working hard and being busy, but that's not the same thing as making progress. So where it's possible, it's important to have some kind of metrics that let you evaluate your progress over time. And so if you set up your research hypothesis well, then it can help you identify what's a good way of measuring your progress. Some places they do this in a very top-down way. They could have a project review. At the end of the project review, they say, "Oh, I'm not satisfied with the progress. Let's cancel it." I prefer to run my organization where people get the chance to reflect on this in their own projects and to steer their projects as a result of how this progress is happening over time. It could well be that the metrics you're using for evaluating progress aren't the right ones, but if you don't have the discipline to measure yourself, then it's hard for yourself to know whether the problem is with the metrics or whether with your work. And it's important when we do these projects to have a culture that doesn't blame people. You can have a great project that fails, and that's okay, but you need to set it up so that it fails for the right reasons. I don't mind the project that fails because the technical hypothesis was not true. I don't mind the project that fails because it tried to be ambitious and things weren't ready yet. I do mind it if you have a project that fails because it was mismanaged and because the people had a lot of internal friction, couldn't get any decisions to work out, and it failed um, because they didn't think through it carefully about what would be needed for the project to be successful at the beginning. So fail, but fail for the right reasons is maybe the lesson. All right, so I have a collection of 5 common failure patterns that I see that I thought might be useful for people to appreciate, and I'm happy to go through those. All right, so the first common failure form is that you create a project that's trying to do everything. It's trying to do some state-of-the-art research, publish some top papers, and also connect to some product teams, and the product team said they like your work, so you're working with them. You're working with them in this kind of weak mixture. You work super hard, but the work you do is not really being critical to any of the product teams you're working with. Like it's a feature they want, but it's a feature that they don't have time to work on, and they are okay if you spend the time to work on it. And this is it feels attractive from both sides, but it's not really a great pattern. You're kind of letting down your research lab if you're doing that. It's much better to work with talk to the product folks and say, what is it that would be really important for them if you did it? Not simply something that if you did it, it'd be okay. Similarly, in terms of academic research or fundamental research or basic research, are you being sufficiently ambitious? Are you just jumping on, train and doing what other people could already do? And also, as a project that has weak research ambition, you could imagine that why is it that someone else in your company who's developing your product is already not working on it? So this is a very common phenomenon. Don't try to do everything in your project. Try to do something, focused set of things, and then you can change over time what your project is doing. But don't spread yourself too thin. Second one is this notion. Some people call it short-term thinking, but I don't really think it's not a short-term or low-hanging fruit work. It's really work that's being driven just by the next conference deadline, or it's targeted by some easy priorities, and you're doing the kind of bread-first traversal of the thing, and you're being driven very much by short-term objectives that seem attractive. So it's not that the problems are important or not, but it's whether you're able to kind of build a deeper set of technology that's going to be important down the line. Now, it's totally fine to do breadth-first kinds of explorations when you're in new areas and you're still getting the team figured out and the connections and so on. But if this is a problem that you're doing kind of year on year, then in many ways, your research team is maybe not doing the best job it could be, because it's again has this kind of mercenary attitude of just consulting on the latest problem that seems relevant. The third one is very popular in research, which is that some trend happens and then everyone changes to do exactly that. And so the question you should ask yourself is, if everyone else is working in that space, how much additional value are you bringing for yourself also to be working in this space? Now, sometimes the trend is absolutely a good trend to have, and you should be switching your paradigm and working in this direction. But other times it seems like you're doing it more from peer pressure than any other reason, and you believe that it's easier to do what everyone else is doing than to spend the time thinking a little bit harder about what is it that you should be doing or your team should be doing. So when you see yourself in a mode of just following on with everyone else, stop and think. And it doesn't mean you shouldn't do that, but you should be careful. And so it's really a lesson of being aware of the pros and cons of just following the trend. The fourth one is that you have this awesome idea and you get super excited about the idea, and you build this amazing solution, and you have trouble convincing other people that this is something amazing. And I've talked to a lot of my colleagues who are really, really excited. They're smart people who come up, spend a lot of time creating this tool that they think is amazing and that everyone should use. And in reality, it's mismatched. It's mismatched because they didn't take the time to understand what is it people actually wanted. Now, it could be okay in a basic research project to create a provocative paper that does something out of the way, because it's a time-bounded thing. But year on year, if you're struggling to convince people that that they need a two-headed hammer because they need to hammer two nails at the same time, and the two nails are always spaced this far apart, then maybe you're not doing your job right. So anytime you come up with something that seems so much better for you than everyone else, it's time to think through it. Now, you could be right. It could be that the other people in your company or your research field have blinkers on. They're not able to see. They're myopically seeing. They're not seeing the potential. And if so, you might be able to convince them over time. But again, it's important to have humility and say, maybe you're the one not seeing the full picture, and maybe you hallucinated and created a problem that then you were able to solve in this awesome way. But if the problem is itself not that important, maybe you should be working on something else. And that connects back to the second question in my previous slides, where if you succeed, do you actually get the best case scenario? And here I would argue that the answer is probably not. And then everyone is encouraged to think about these moonshots and big ambitious projects. And it's great to be working on a project that's very ambitious, but you also have to be realistic, and you have to look at the company that you're in, the lab you're in, and you think about it and you say, am I really being given the resources to succeed on this very impressive, ambitious project? Or is it simply that people want me to work on it because it seems attractive to them? And if the answer is that you don't have if you don't really think that the resources exist so that this moonshot can happen, then you need to have the right conversations. Now, in some cases, it could be that you're saying you want to do this very ambitious research, and the company can the management can say, well, sure, convince us through something smaller scale that you're the right team in which to invest. And then, of course, you can do that. But if it turns out that you're expected to do something that's infeasibly ambitious because your team lacks either the resources or the skills or the right number of people, or the set of
Oh, sorry, let me maybe just mute him.
Oh, no worries.
Oh.
That's totally fine. Yeah, so anyway, so this last anti-pattern is really about matching the needs of your team, the skills in your team to the needs of the project, and make sure that you're aligned. All right, so with that, we come to the end of the talk itself. I provided you some of the the ways in which things can go wrong in industrial research. The first one, of course, is you should become comfortable with change. So the change that happens is often also an opportunity, and you can think about ways to navigate that. Second one is that while there are many skills that transfer really nicely between academia and industrial research, the two are different. And there are many cases where people who are really good at one, when they switch over, have difficulty in the other. And it's important to view yourself with humility and to learn the skills that you need. And I've had to do that many times. And I think that if you are in a position where you're switching between academic research and industrial research, take the time to think through what are the skills you need to learn. Choose your projects carefully. Sometimes you have the option of choosing which project you're working on as a junior researcher, or as a more senior researcher, you might be thinking about what projects do I start. So think through what projects you either work on or create or nurture or encourage in your teams. And then, of course, the last one is that you're working in a world that's stochastic with incomplete information. And so you should appreciate that you're not going to be able to make a decision that's perfect. You're going to have to make decisions, and you have to be conscious of the trade-offs of the decisions that you make. And becoming conscious of those trade-offs helps you make better decisions, because then when the downsides of the trade-offs are revealed to you, either by other people or by the circumstances, you're not caught off surprise. You're able to say, okay, yeah, that's true. This is a serious problem, but it's not one that you're approaching in a surprised state of mind. So with that, I think we've reached the end of the talk, and can probably end the recording. Thank you so much, Mike, for inviting me, and I look forward to catching up with all of you at the panel discussion, and we can stay on for some time and catch up in the chat here as well.